Team ID NI-130. Our project is GATSIC bot, which is Generalized All-Terrain Surveillance Intelligent Cluster Bot.
Coming to the mechanics of the bot, it is a hexapod with 6 C-shaped legs, similar to the RX of Boston Dynamics. But unlike the RX, the GATSIC is equipped with high traction all-terrain wheels, which gives it excellent maneuverability on flat surfaces. The GATSIC is designed using the Autodesk Inventor, with the main design constraints such as lightweight aluminum chassis, robustness, and compact structure, enabling an efficient all-terrain movement. Now coming to the analysis part, here we have the analysis of the factor of safety of a sea leg. Now the factor of safety comes around 6.3, which is very good, and it indicates that our sea leg has high strength and can withstand heavy loads. Now the displacement analysis. The displacement is the movement of the sea leg under heavy load. Now when the sea leg is rotating, it occurs lots of load, so the sea leg moves up and down a bit. Now here the maximum displacement is 5, which is very good for us. Next coming up here is the stress analysis of the sea leg. The stress analysis is like how the variation of the stresses come about on all parts of the sea leg. Now here you can see the sea leg under flexing. The maximum load is at the center of the sea leg. Here we can see the manufacturing of the chassis using water jet cutting. The chassis is made out of aluminum, and we also use water jet cutting for a C-shaped leg, which is made out of nylon 6/6. This is the end product of the cutting up of nylon 6/6 C-shaped legs. Here we can see the we started out with cast iron C-shaped legs, then we went to mild steel, and now at the end we are with nylon 6/6.
Now let's go through the lab UI for our GATSIC bot. So this is basically the front panel of the VI, and it basically consists of main components are like the accelerometer graph values, and this we basically use for getting input from the graph and for controlling the bot autonomously when it travels in various kinds of terrains. And we also have the camera surveillance panel over here, and an emergency stop is present here in case the bot has to travel in low power mode, etc. like that. And the main switch off control is here. The main actuator controls are present over here. We basically use two kinds of actuators in the GATSIC bot. The one is servo control and the normal motor controls. The servo control basically is for the RX like compliant legs, and the motor control, when the RX is not active in active mode, we use this motor control. In servo control, first servo calibration happens, and then servo initialization, and the four main motions like front, back, and wheel mode and normal mode. Wheel mode is basically a semi-half circle mode that gets actuated such that these mode will come into actuation. So wheel mode and then normal mode comes into normal actuation modes. And when the wheel mode is in actuation state, the forward, backward, motor left and motor right comes into actuation. And we also put an indication panel over here so that it will indicate when the process is still running. So this is about the front panel of this VI. And now let's move on to the block diagram. Okay. So in order to show all the VIs at the same time, I've just expanded all the sub VIs which I made into a single block diagram structure. So it has three main structures, three main event frames: the initialize, acquire, and the end. So initialize is basically initialize in MyRio. In the acquire and process data, main loop is present. In the main loop, first thing is the servo calibrate. Servo calibrate basically calibrates the servo to initial values, and then all other states are present: servo front stop, but normal mode, servo initialize, etc. And the accelerometer structure is present here. And this is basically for the ultrasound. This conversion diagram converts like ultrasound values and gives the corresponding distances so that it will be able to actuate in autonomous mode. And here, these four are for the motor controls in the wheel mode, and this is for the camera module. I just expanded all the VIs just for showing you the complete structure.
Okay, while the mechanical work is still going on, let me just use this time to explain the internal component connection structure. So when coming to sensors, first we use the Logitech 720p camera in the front, and the rangefinder sensor, ultrasonic sensor, and the actuators. We use two major actuators. One is the servo. Servo we use Rhino RMCS, and the smaller actuator, the motor, the DC motor, it's Johnson gear, 100 RPM I guess, and everything is connected to Myrio. And what else? So that's it. This is the major components, sensors and actuators on the controller part of the board. And apart from this, we do have other preliminary sensors which will be attached to the board later.